Hello friends, this video on atoms part 8 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos till part 7 before going ahead with part 8. Now let us come back to Bohr's model of atom. So let us see what did Bohr do to incorporate the limitations which were there in the Rutherford's model of atom. So Bohr's model of atom told that it used the emission spectrum of hydrogen to develop a model for hydrogen. So Bohr's model of atom basically focused on the model of hydrogen atom. This again became a drawback for the Bohr's model, but however for hydrogen Bohr could explain everything to a very large extent. Right? So what did Bohr do? He used the emission spectrum of hydrogen, and with the help of that spectrum he developed a model for hydrogen atom. He postulated that electrons move around the nucleus in circular orbits. Okay, this was something similar to what Rutherford had told. Bohr's model determines the radius of each circular electron orbit. Okay, so even Rutherford had told that electrons are moving in circular orbits. Bohr calculated the energy of electron in various orbits, and for each orbit predicted the distance between the electron and the nucleus. Right? So in case of Bohr's model, he mentioned the exact energy orbits which the electron can occupy. It is not that electron can occupy just any orbit. So there are some specific orbits in which the electrons can revolve around the nucleus. So it offered a satisfactory model for explaining the spectra of the hydrogen atom. So this was a major drawback of the Rutherford model. Only certain orbits can exist, and each orbit corresponds to a specific energy. Electron energy is quantized, right? So Rutherford never talked about quantization, but Bohr told that it is not that electron can revolve around the nucleus in just any circular path. It is not like that. There are certain orbits, or there are certain circular paths only through which the electrons can revolve around the nucleus. So that means the electron energy is quantized. Electron energy is not continuous. It cannot be just any value. It can only be, there are a set of discrete values which are only allowed. Right? So these were some of the postulates of the Bohr's model of atom, and with this we will start understanding Bohr's model. So before that, we will get a little more knowledge on atomic spectra, because if you are not very much clear with the different types of atomic spectra, it will become difficult for you to understand the postulates of the Bohr's model. As I mentioned, Bohr started his theory with the emission spectra of hydrogen atom. So for that you should first have a bit more idea on the atomic spectra. So now we will discuss about the different types of atomic spectra in detail. So before that, let us talk about continuous spectrum and quantized spectrum. What is a continuous spectrum and what is a quantized spectrum? So let us talk about the continuous and quantized spectrum. So what is before we talk about spectrum, let us just differentiate between the two terms, continuous and quantized. When I say continuous, I mean a value which keeps changing continuously. Let us suppose right now it is at this point, then it is at this point, here. So if you look at this value, this is changing continuously, right? So at every instant, it has got a different value. So it is changing continuously. Whereas if you look at a value like this, so in this case, if you see, at every point it has got a distinct value. It is either high or it is low. It is either high or it is low. So that means it has got some discrete set of values. We talked about continuous and quantized when we were talking about analog and digital signals. You remember? So when we were talking about digital signals, we said that it can take only two values, either 0 or 1. So that means there are a discrete set of values which are only allowed. It cannot take any other value except 0 and 1. So similarly, in case of continuous spectrum and quantized spectrum, when I say continuous spectrum, that means the energy can take any value. Energy can be 1, energy can be 1.2, Energy can be 5, energy can be 10, energy can be any value. But when I say quantized spectrum, that means there are a certain values of energy which are allowed. Let us suppose if the allowed energy values are 1, 2 and 3, it cannot have any other value except those 3 values, right? So quantized spectrum means a spectrum which consists of spectral lines, very specific spectral lines. That means it has got only discrete allowed spectral lines, whereas a continuous spectrum means it has got a spectrum which does not have discrete lines. It has got a band in a continuous range, right? So if you look at this continuous spectrum here, what do you see? You see that here it is dark, it gets lighter, 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 and here it is light, right? So it is changing continuously. But in this case, if you see, there are discrete lines at places. So that means when I talk about quantized spectrum, we are talking about specific values. When we are talking about continuous spectrum, we are not talking about specific values. So look at this example, which will make your understanding even clearer. In the first, you see that there are no stairs. It is a continuous change. I mean, the girl reaches from this point to this point. That means here also the girl travels this height h. But in this case, there are no discrete energy levels. It is changing continuously. But in this case, there are discrete levels. 1, 2, 3, 4. So there are 4 discrete levels which are only allowed. So the girl is allowed to step only on these 4 stairs. So she cannot step somewhere in the middle of these 2 stairs, right? So these are the 4 stairs where she is allowed to step. So this is your quantized spectrum. In this case, the girl is allowed to step anywhere she wants, right? So it is changing continuously. So this is a continuous spectrum. Now, why are we talking about quantized spectra? That's because when we look at the atomic spectra, we see that there exists spectral lines. So whenever we see distinct spectral lines, we are talking about quantized spectrum. So this is the evidence for the quantized electronic energy levels. So atomic spectra becomes an evidence for the existence of quantized spectra. So now let us discuss each of this spectra in detail. So we will talk about continuous spectrum, emission spectrum and absorption spectrum. Let us start with continuous spectrum. It is observed when a ray of white light is passed through a prism, the wave with shorter wavelength bends more than the one with a longer wavelength. We have discussed these things in detail, right? We have talked about the phenomenon of dispersion of light in one of our earlier lessons, right? So the spectra which we obtain in this case is a continuous spectra. If you see, it is not, you are not able to see any discrete line, right? It is like gradually the violet becomes blue and then the blue becomes yellow, it becomes red and so on. So that means the change in the colors, it happens gradually, right? So this kind of spectra is known as a continuous spectra. The speed, in this case, why this spectra happens, that we already know, right? Because white light consists of many different colors and each of these colors has got a specific wavelength. Now, each wavelength, when they pass through the prism, they get deviated at a different angle. So because of these different angles of deviation, they get deviated in different ways. The speed of light depends upon the nature of the medium through which it passes. As a result, the beam of light is deviated or refracted from its original path as it passes from one medium to another. We have discussed this dispersion of light in detail, so I will not spend more time on this. The light of red color, which has longest wavelength, is deviated the least, while the violet light is deviated the most. The next one is the emission spectra. The spectrum of radiation emitted by a substance that has absorbed energy is known as emission spectrum. That means whenever you supply some energy to a substance, it gets excited, as I mentioned before also. I mean, when you do not supply any energy, every object is in its ground state. That is the most stable state. Most stable state means the state of minimum energy, right? As soon as you supply some external energy, what happens? That atom goes into the excited state. By absorbing this energy, that atom emits a radiation. So that radiation is known as, or that spectrum is known as the emission spectrum. So the spectrum of radiation emitted by a substance that has absorbed energy is called emission spectrum. To produce an emission spectrum, energy is supplied to the sample either by heating it or by irradiating it, and the wavelength of the radiation emitted as the sample gives up the absorbed energy is recorded. That means, let us suppose this is the substance. This is your substance. You give some energy to this substance. So what happens? This substance will absorb this energy and give out emission spectra. So this emission spectra is the result of the energy which is absorbed. Right? Let's look at the absorption spectrum. An absorption spectrum is like the photographic negative of an emission spectrum. As I mentioned, whenever we supply some energy to an object, this is my object, I supply some energy E to this object. So this substance is absorbing the energy. So some energy it will absorb and the remaining will be emitted as emission spectra. Now what about the energy which is absorbed? So the energy which is absorbed, that is given as the absorption spectrum. It is somewhat like this. Let us suppose you have there is a 10 rupee note in a drawer, right? There is a 10 rupee note in a wallet. The wallet is right now placed on a table. So the 10 rupee note is intact. Now this wallet comes to your hand, right? So in this case, you are the subject. I mean, you are the substance now. Now, as soon as that wallet comes to your hand, what happens? Out of those 10 rupees, you take 5 rupees. So how much is left? 5 rupees. So the remaining balance is 5 rupees. Now the wallet again goes back to the table. But now what is there inside the wallet? It is 5 rupees. So what happens to the remaining 5 rupees? It is absorbed by you. So this remaining 5 rupees, here is the amount which is absorbed. So whatever is absorbed is given as or is emitted as absorption spectrum, and whatever is remained is given as the emission spectrum. So you understand the difference between emission spectrum and absorption spectrum? The incident radiation falls on an object. Some part is absorbed, which is given as absorption spectrum, and the remaining part is emitted as emission spectrum. Therefore, it says that the absorption spectrum is like a photographic negative of emission spectrum. That's because whatever is not present on the emission spectrum is present on the absorption spectrum. Here, 5 rupee was missing. So, where is that missing 5 rupee? It is in the absorption spectrum, right? So, an absorption spectrum is like the photographic negative of an emission spectrum. A continuum of radiation is passed through a sample which absorbs radiation of certain wavelength. The missing wavelength, which corresponds to the radiation absorbed by the matter, leaves dark spaces in the bright continuous spectrum. You understand it in this way. This is how you get your absorption spectrum. What does this mean? It means that these lines represent the radiations which have been absorbed. So that means whatever your incident radiation was there, from that incident radiation, only these parts, if you subtract, the remaining will be your emission spectrum. So if you think of an emission spectrum, it will be just the reverse of this. In case of emission spectrum, these areas will be dark and the remaining areas will be bright, right? So let us have a comparison of all the three spectrum. So when I talk about continuous spectrum, it is somewhat like this. You don't have distinct specific lines, right? So this is my continuous spectrum. That is clear. When I talk about emission spectrum and absorption spectrum, what is the difference? When I talk about emission spectrum, I have got specific lines, right? Like whatever my incident was, whatever my incident radiation was, the same was absorbed except the one which are absorbed. So what is absorbed here? Now in emission spectrum, these are my dark areas. That means these are the missing areas. Now where are these missing areas gone? They are in the absorption spectrum. So this is my absorption spectrum. So the absorption spectrum will be bright where the emission spectrum is dark. Right? It is similar to the example of the 10 rupee note example. So you had 10 rupees in the wallet, you took out 5 rupees. So remaining is 5 rupees. So So this emission spectra is the remaining balance. So in emission spectra, if you see so many black region, that means these are the regions which are missing in the emission spectrum. That means these regions will be colorful in the absorption spectrum. Right? So this is the difference between emission spectrum and absorption spectrum. So I hope I am able to explain you what are the different types of spectrum.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.